morning, viewers. Welcome to MouShauk. Today, I'll start with the uses and the preparations of. Okay, I'll discuss these two topics. So, before I start, I would request you to please to subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. Okay, and if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And please do meditate if you when you start your day, before you start your day, please do meditate, okay? So we will also start with a short meditation. For meditation, let us concentrate on the point of light, okay? Think that light is falling on you and you are feeling very enlightened, very light. All your problems are gone. You're feeling very relaxed. You're feeling control. All your whatever problems you're getting resolved very easily. You're getting strength. You're getting energy. And you are completing your work very easily. You're getting interest in your job. Whatever you are doing the whole day. And at the end of the day, you're thanking God for being with you the whole day and giving you such energy and power to handle each and every work you are doing the whole day. Okay. So thank you. We'll stop here and come to the discussion. Okay. So when we are talking of hydrogen, in my last video, I told you, we discussed about the placement of hydrogen in the periodic table, why it is called the first element of the periodic table. Okay. So we found the occurrence where it has occurred, and these things we discussed in my first video, and now we have come to the preparations of hydrogen. So why do we need to prepare hydrogen? Why hydrogen is needed? Okay, what is the importance of hydrogen? Why do we need to study hydrogen? What's the need for us to study this hydrogen, so that we have to prepare it for our daily uses? Okay, so we will see that what are the uses of hydrogen first, and then we will go to the preparations of hydrogen. Okay, so what are the uses? In general use, hydrogen is used as a fuel. Okay, it is used as a coal gas, it is used as a water gas, it is used as a liquid hydrogen due to its high heat of combustion. When it is burned, it radiates a large amount of heat. Okay, and that's why it is being used as a fuel, like for coal gas, water gas, and liquid hydrogen. Okay, water gas is a combination of carbon monoxide and hydrogen. Okay, and liquid hydrogen is a non-polluting and easy to store. That's why it is used as a fuel. Okay, now another use of hydrogen is oxyhydrogen torch. Okay, that is used for cutting and welding of metals. We have seen in many grill shops, where their grills are made. Okay, so we can see that they use a machine through which fire is coming out, and they are cutting the metals, iron rods they're cutting. So that is known as oxyhydrogen torch, which we see in the cutting and welding places. Okay, they are used for cutting and welding metals. Okay, so this is a combination of two gases, that is hydrogen and oxygen together. The two gases are used, which is in a torch, which is known as oxyhydrogen torch, and they produce a temperature of 2,500 degrees centigrade. Okay. This oxyhydrogen torch, this is used for cutting and welding metals, for melting platinum and quartz. Okay. Then for fusing alumina, producing synthetic rubies and sapphires. fusing alumina. They fuse the alumina for producing what? Rubies and sapphires. That is synthetic. That's not natural. Okay, which are used in jewels in the watches. Jewelry in the watches, no. Some watches they have jewels on them. So those are made up of generally synthetic rubies and sapphires, and that is made by fusing of alumina, which is fused by oxyhydrogen torch. Okay. Then an atomic hydrogen torch is also used for welding alloys. Okay. Welding means joining the metals, and cutting means cutting it. Okay. Separating it apart. So atomic hydrogen torch, it also creates a high temperature, that is very high temperature, that is 2800 degrees centigrade. Okay, oxyhydrogen torch that produces 2500 degrees centigrade, and this atomic hydrogen torch that produces 2800 degrees centigrade. Okay, it welds alloys which contains the metals like tungsten, manganese, chromium. Okay, and then it is also used in self-lightening gas jets and automatic lighters. Okay, automatic lighters which are used, those have what? Those have this hydrogen. Okay, then manufacturing of ammonia. For manufacturing ammonia, and ammonia, the formula is NH3. So there is hydrogen present in the compound. So that for this manufacture of this compound, hydrogen is used. Processes, Haber's process. Okay. Then for hydrogenation of vegetable oil. Okay, that is preparing solid vanaspati ghee from liquid vegetable fats. From liquid vegetable fats, solid vanaspati ghee is produced, that is known as hydrogenation of the vegetable oil. Okay, so vegetable fats means then liquid vegetable fats, that can be groundnut oil, coconut oil, etc. in the presence of. The process occurs in the presence of finely divided nickel or platinum or palladium, which are used as catalysts. Okay, these nickel, platinum, or palladium, these are catalysts. They are used as catalysts. In presence of this catalyst, groundnut oil or coconut oil or any other vegetable fat oil liquid, that is converted into vanaspati ghee, solid vanaspati ghee by hydrogen. Okay, at a high temperature of about 200 degrees centigrade. Okay. Then hydrogen is also used for producing artificial petrol from coal. Okay, the coal should be in the powdered form, and hydrogen is passed over this powdered form of coal at a high pressure in presence of a catalyst. Here also catalyst is used, but the pressure should be high, and the coal should be in the powdered form. Then artificial petrol is created. Okay. Then in the extraction of the metals, certain metals are extracted from the metallic oxide. These metals should be very less active metals. Otherwise, if we use very highly active metals like sodium, potassium, they will not be reduced by, their oxides will not be reduced by hydrogen, because the active metals, the more active, the highly active metals, they have an affinity of oxygen. So they will be they will be almost fused to the oxygen. They will not leave that oxygen apart, okay, from them. That's why the hydrogen will not be able to reduce them into their metals. Okay, so these type of less active metal oxides are used to produce their, to reduce them to their metals. Okay, less active metal oxides like iron oxide. Okay, and then this one, black copper oxide, that is reduced to copper, or iron oxide is reduced to iron. Then we come to, so we know now what is the use of hydrogen, why hydrogen is needed to be prepared. Why do we need to prepare hydrogen for, for different purposes, as we need to prepare, as hydrogen is needed for different purposes, we need to prepare it artificially. Okay, and that is why we need to study these preparation methods. Okay, so without studying, we will not be able to produce hydrogen. Okay, because there is some ways that are given in this chemistry, and that will help us to know how to prepare it. So first, we come to the general methods of preparation. First reaction is reaction of metals with cold water. Okay. The first active metals. Okay, some active metals. In the activity series, the active metals are first considered because these active metals, they react with cold water to produce hydrogen. For example, first is potassium, then comes sodium, then comes calcium. These three metals are highly active metals. They react with cold water and they produce hydrogen. Okay, so when we put some potassium in the cold water, we will see it will float on the water because it has a density of 0.86 grams per cubic centimeter. Okay, it is slightly less dense than water. Okay, that's why it floats on water. Now it melts at 62 degrees centigrade. Okay, this potassium that melts at 62 degrees centigrade. When potassium reacts with cold water, it's an exothermic reaction. That is, it generates heat. And when it is generating heat, the potassium starts melting. Okay, and when it is melting at 62 degrees centigrade, when the temperature reaches, it starts melting. Okay, so when it starts melting, it forms a silver gray globule which darts about on the surface of the water. Okay, so it's a highly exothermic reaction. It's a highly vigorous reaction. The reaction is in such a way that 2K plus 2H2O gives us 2KOH plus H2. So potassium reacts with water to form potassium hydroxide or caustic potash, and hydrogen is released. Okay. Now this caustic potash is an alkali. Okay, it's a base because it forms a soapy. We will understand from it the solution which turns into soapy type of structure. So that indicates that the potassium has changed to the potassium hydroxide. Okay, and this potassium, when it catches fire, it produces a lilac colored flame, slightly light violet colored flame. Okay, and hydrogen gas bubbles out. Okay, we can see that hydrogen is bubbling out, which shows that hydrogen has been liberated. Okay, the solution will turn into colorless solution, soapy and alkaline. Okay, this indicates that potassium hydroxide has been formed. Okay, generally hydrogen burns with a pale blue flame, but as potassium is burning in the hydrogen, so it will burn in a lilac color. Okay, and then we come to sodium. Sodium also is a very active metal, but this reaction is also vigorous, is also highly vigorous and highly exothermic, but less vigorous and less exothermic than potassium. Okay. The sodium also has a less density than water. That's why it also floats on water. Its density is 0.97 grams per centimeter cube. Okay. And it melts at 97 degrees centigrade. The process is same. That is, the temperature when this reaction takes place, there lots of heat is generated, which starts melting this. And when the temperature rises to 97 degrees centigrade, the sodium starts melting. Okay, and when it starts melting, it darts about on the surface of the water. Silvery globule it changes into. Okay. So the reaction occurs in this way, that is sodium reacts with water, that is 2Na plus 2H2O forms 2NaOH plus H2 gas. Again, hydrogen gas evolves as bubbles, okay? And the sodium catches fire, okay, due to the exothermic reaction, it catches fire and burns with a golden yellow flame, okay? And the solution turns colorless, soapy, and alkaline, and slightly warm also. Okay. Now that's why as these two metals, sodium and potassium, catches fire very soon, very easily, and it's a very highly exothermic reaction. So what happens? So generally sodium amalgam or potassium amalgam is used. That means amalgam is nothing but sodium or potassium is in combination with mercury. It is an alloy which is used for the preparation of hydrogen from sodium and potassium. Okay, and that's why it will react smoothly with water. Not so vigorous reaction takes place and not so highly exothermic reaction takes place. Okay, from this hydrogen, from this amalgams, hydrogen can be prepared very safe. Okay, now we come to calcium. Calcium with cold water, it reacts with cold water, but calcium is a denser metal than water. That's why it sinks in the bottom of the vessel. Okay. Now, it is a less vigorous reaction than sodium, and the reaction takes place in this way. That is, calcium plus 2H2O gives us CaOH whole twice and hydrogen. See, here the funnel is there, and the calcium metal has sunk into the bottom of the beaker, and the funnel is inverted, and from the inverted funnel, the tip of the funnel, the tail of the funnel, this one hydrogen gas will come out as bubbles, okay, and it will collect over water. Okay, now the solution will turn milky, turbid, and alkaline because of the formation of calcium hydroxide. Okay, and these three metals, as their hydroxides are formed and hydroxides are alkaline in nature, they will turn red litmus blue, because that's a test for the alkali, because red litmus solution turns alkaline solution. In the presence of alkaline solution, the red litmus turns blue. Okay. Now we come to some metals which are used on hot water. Okay, when hot water is used on these metals, then hydrogen is produced. In the previous three reactions, the cold water was sufficient for the reaction to take place and hydrogen to be liberated. But here, hot water is needed. Like magnesium requires boiling water. Okay, magnesium slowly reacts with boiling water, forming magnesium hydroxide, that's a base, and hydrogen is liberated. The reaction takes place in this way, that Mg plus 2H2O gives us MgOH whole twice, and hydrogen is liberated. Now, if we add steam to magnesium, if we give steam to the magnesium, then what happens? Now, in this apparatus, we will see that there is a round bottom flask where there is boiling water is kept, which is liberating steam. Okay, and through this steam, through this tube, from the steam is passed into a tube is there which contains magnesium ribbon. Okay, and it burns in this the magnesium ribbon burns in the steam, and an intense white light is produced, which changes into white ash of magnesium oxide. Magnesium ribbon burns into the in the steam and produces intense white light, and white ash is produced of magnesium oxide. This magnesium oxide crumbles down due to the heat, and hydrogen is produced, which passes from this tube through the, it comes down through this tube, and through the beehive, it collects over water. Okay, on further heating, this hydrogen gas is released, and this is collected over water. Okay. Now, next is reaction of metals with steam. Okay. Aluminium with steam. Now we are requiring more heat into the water. That is, first there was cold water, then boiling water, then steam. Now we have come to steam, which is reacting with the metals. As we are coming down in the activity series, so first is potassium, then sodium, then calcium, then magnesium, then aluminium, then zinc. So we are coming down. So aluminium reacts with steam. Okay, reacting with the steam, liberating hydrogen, forms alumina. Okay, aluminium oxide. Okay, which forms a coating and thus makes the reaction inactive. The reaction starts. Okay, the reaction starts, but what happens after the production of aluminium oxide? Okay, Al2O3. What happens? A coating is formed on the aluminium, on the metal aluminium, and the reaction stops. The steam does not react with aluminum oxide, okay, and this reaction stops producing hydrogen. Okay, on further, if we further raise the temperature, if the temperature is raised further to 800 degrees centigrade, this coating breaks and hydrogen starts liberating again. So aluminum oxide will be formed, but to continue the reaction further, that is to produce hydrogen, we need to raise the temperature to 800 degrees centigrade. So steam is used and 800 degree temperature, 800 degree centigrade temperature is also used to produce hydrogen from aluminum. Okay. Then if we come to zinc, zinc is less reactive than aluminum. So in the activity series, then comes zinc. Okay, zinc is less reactive than aluminum. So it reacts only when zinc is heated. Here, zinc is also heated, steam is also there. Okay, so both are hot. Water is also hot, that is steam in the form of steam, and zinc is also heated. Okay, and white zinc oxide is formed there, and hydrogen is liberated. Okay, now hot zinc oxide is yellow in color, but when it is cool, it becomes white. Okay, so the reaction occurs in this way. Zn plus H2O forms ZnO plus H2. Now iron. Iron is again less reactive than zinc. Here, it was hot. Zinc was hot, but here iron is red hot. That means more heat is required for the metal. And steam is also there. So water is also hot, and the iron, the metal is red hot. Okay, because in the reactivity series, the metals are coming down, they are becoming less reactive now. Okay, now it forms what? Tri-iron tetroxide and hydrogen is liberated. And this reaction is a reversible reaction. If the hydrogen that is formed is not removed, then it reduces back to iron. Iron oxide reduces back to iron, and hydrogen gets oxidized to water. So the apparatus here, it is used in this way, that there's a flat bottom flask is used, which has boiling water, which is liberating this one steam. Okay, there should be a stopcock here. Okay. There should be a stopcock. Okay, there should be a stopcock here. So that it does not come out automatically. It should pass through this tube, which contains the the tube is of silica glass tube. It is, and it has the glass steel wool. Okay, that is it contains iron. Steel wool is nothing but iron. Okay, and this steel wool should be red hot, and steam is also passed through this. Okay, and what happens? The hydrogen is being liberated. Here, Fe3O4 is being formed when steam is passed through it, and hydrogen is being liberated here, which is collected over water. Okay. Then see, as the speed of the reaction is directly related to as the speed of the reaction is directly related to the masses and masses or commutations of the reacting substances. Okay. In the beginning, the forward reaction is fast and the backward reaction is slow. What happens in this reaction? The forward reaction, as it is a reversible reaction, the forward reaction first is fast. At the beginning, the reaction, the forward reaction that is towards the formation of hydrogen, that reaction becomes fast. And the reverse reaction becomes slow. Reaction is slow. Okay. Because the reactants are more. But as the reactants are getting consumed, what happens? The forward reaction becomes slower and the products as formed more, no? So the backward reaction becomes faster. Now, at a point of time, what happens? Both the reactions, that is forward reaction and backward reaction, they become equal. Okay. At that point, the reaction is known as chemical equilibrium or equilibrium state. This occurs at 700 degrees centigrade. In this particular reaction, at 700 degrees centigrade, this chemical equilibrium comes. When it is an equilibrium, what is chemical equilibrium? It is an equilibrium that is attained through a chemical change. That is, the forward reaction equalizes, the speed of the forward reaction equalizes the speed of the backward reaction. Clear? Then the metals, the reaction with the steam, the rate of reaction in case of magnesium is the fastest. Okay, when the metals are reacting with the steam, magnesium reacting with the steam, that is fastest reaction. Progressively, it decreases in case of aluminium, zinc, and iron. That is, magnesium with steam reacts much faster than aluminium. Then comes zinc, and then comes iron. Rate of reaction becomes slower. Okay. Now, the reaction in case of magnesium, aluminium, and zinc stops after some time due to the formation of the oxide, which forms a coating over the metals, respective metals, okay, which will not allow the steam to come in contact with the metal, and thus the reaction stops. On further heating, this coating breaks, and then the steam comes in contact with the metal, and the reaction proceeds, forming hydrogen. Clear? Next, we come to the reaction of non-metals with steam. Okay. Now, when non-metals come with steam, like carbon, when it comes with contact with the steam, what happens? Water gas is formed. Okay, that is carbon, which is in the form of red hot coke. When steam is passed over red hot coke, then water gas is produced. That is carbon and hydrogen, carbon monoxide and hydrogen. Combination of these two gases is known as water gas, which is used as fuel. We know that. We have come across it in the uses of hydrogen. Okay? Next is reaction of active metals with dilute acids. Okay, this we have come across all the reactions with water in the form of water, hot water, then steam. Now we come to dilute reaction of active metals with dilute acids. Now hydrogen is displaced from dilute HCl and dilute H2SO. Mind it, dilute HCl, that is hydrochloric acid, dilute sulfuric acid. Not with dilute nitric acid, not with dilute concentrated hydrochloric acid or concentrated sulfuric acid. To produce, when these metals come with these only dilute hydrochloric acid or dilute sulfuric acid, then only they will release hydrogen. Okay. Even I will tell you another thing is that the metals which are more reactive than hydrogen, they will only react with dilute hydrochloric acid or dilute sulfuric acid to produce hydrogen. Okay. Now, the extent to which these reactions occur by a metal is based on the activity series of the metals. I told you there's an activity series of the metals. That is, the metals are arranged in such a way in a series, okay, which will show that which metals are more reactive and which metals are less reactive. The metals which are placed above hydrogen, they are more reactive metals, and the metals which are placed below hydrogen, those are less reactive metals than hydrogen. So let us see. It is a series of metals that are arranged in the decreasing order of their reactivity, known as activity series of metals. Now let us see the activity series of the metals. See, First, above hydrogen is potassium, sodium, calcium, then magnesium, aluminium, zinc, then iron, nickel, strontium, and then lead. Sorry, tin and lead. Okay. Now, then comes what? Below hydrogen is copper, mercury, silver, and gold. Okay. So this potassium, sodium, and calcium, they displace hydrogen from dilute acids. Okay. Dilute acids means hydrochloric acid or sulfuric acid explosively. Very vigorous reaction takes place with these dilute acids to form the hydrogen. Magnesium, aluminium, and zinc, they displace hydrogen from dilute acids, that is hydrochloric acid and sulfuric acid, vigorously but not explosive, not so violent, from their respective salts, forming their respective salts are also formed here. Then iron, nickel, tin, and lead, they displace hydrogen from dilute acids, hydrochloric acid and sulfuric acid gently, forming their respective salts. Then copper, mercury, silver, gold, they do not displace hydrogen from their dilute acids. Okay. Now, these is known as activity series. The activity series, you can see the arrow from potassium to gold, the reactivity decreases. Okay. That is, potassium is highly reactive, then comes sodium, then comes calcium, then comes magnesium, the reactivity slowly comes down. Okay, or you can say the other way around, that is from gold to potassium will go up, the reactivity increases. Okay. Now let us see the reactions. Magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen. Sulfuric acid forms magnesium sulfate and hydrogen. Aluminium forms aluminium chloride and hydrogen with HCl. With H2SO4, it forms aluminium sulfate and hydrogen. Zinc with hydrochloric acid, zinc chloride and hydrogen. Zinc with sulfuric acid, zinc sulfate and hydrogen. Iron with HCl forms FeCl2 and hydrogen. Fe plus H2SO4 gives us FeSO4 plus H. Now comes the question. Why nitric acid is not being used? Because nitric acid reacts with metal, producing oxides of nitrogen. Okay, other metals which will react with the metals, only magnesium and manganese, they react with nitric acid to produce hydrogen. Other metals, that is potassium, sodium, calcium, then aluminium, zinc, iron, all these metals, they do not produce hydrogen. Why? They produce oxides of nitrogen and or ammonium nitrate and not hydrogen. Because why? Because it is an oxidizing agent. Nitric acid, dilute nitric acid, that is an oxidizing agent. Okay, it will not react with other metals except magnesium or manganese to produce hydrogen. It will form oxides of nitrogen or ammonium nitrate is formed and not hydrogen is formed. Okay, so let's see, manganese reacts with nitric acid with magnesium nitrate and hydrogen. Magnesium forms, and manganese also nitric acid reacts with to form manganese nitrate and hydrogen. Okay, lead is not used in the preparation of hydrogen. Why? Another question, why lead is not used in the preparation of hydrogen? Because by using dilute hydrochloric acid or dilute sulfuric acid, insoluble lead chloride or lead sulfate will be formed, which will settle on the fresh lead metal, and that will prevent the reaction from the moving forward. Reaction of the metal with the acid will cut off and the reaction will stop. So insoluble lead chloride or insoluble lead sulfate will be formed. If it is with dilute hydrochloric acid, then lead chloride, insoluble lead chloride will be formed. If it is dilute sulfuric acid, then insoluble lead sulfate will be formed. That will settle on the lead and that will cut the contact of the metal with the acid and no further reaction will take place. Okay. Now reaction of metals with alkalis. Alkalis means hydroxide, that is sodium hydroxide, potassium hydroxide. Okay. So these should be in concentrated form. These hydroxides should be in the concentrated form. Another thing, zinc, lead, and aluminium, they are amphoteric in nature. That is, they react with acids as well as with the bases. Sodium hydroxide, potassium hydroxide, they are bases, they are alkalis. Okay. And zinc, lead, or aluminium, these metals are amphoteric in nature. That is, they react with both with alkalis or with acids to produce salt and water. They can react with these bases or with acids. Okay. They react with concentrated alkalis, sodium hydroxide or potassium hydroxide in the powdered form. They should be in the powdered form. The alkalis should be in the powdered form, producing the soluble complex salts, and hydrogen is liberated. Okay. What are the complex sodium salts that are formed? When zinc reacts with sodium hydroxide, forms sodium hydroxide and boil, then sodium zincate is formed. Zinc reacting with concentrated potassium hydroxide, potassium zincate is formed. Aluminium react with sodium hydroxide, then sodium meta-aluminate is formed. Mind the formula NaAlO2. Okay. Because you need to memorize the formula, practice it, write it down. Lots of times, practice it, otherwise you will forget this formulas. Okay, you need to remember the formula. Then aluminium and reacts with potassium hydroxide and water. In the solution form, it is reacted. Okay, potassium hydroxide and sodium oxide with water. Solution form, it is reacting with aluminium to form their meta-aluminate, and hydrogen is being liberated. When fused sodium hydroxide is used with is reacted with aluminium and boiled, then sodium aluminite is formed in a 3AlO3. Okay, this sodium aluminite is formed with hydrogen. Then lead reacting with sodium hydroxide, then sodium plumbite is formed in a 2PbO2. Sodium plumbite is formed, or potassium hydroxide, then potassium plumbite is formed. Okay. Now, see, another note is that oxides and hydroxides of zinc, lead, and aluminium, they are also amphoteric in nature. I told you these metals are amphoteric in nature. Even the oxides and hydroxides of these metals are also amphoteric in nature. That is, they react with base or they react with acid to form salt and water. Okay. They react with bases, like zinc oxide react with hydrochloric acid with acid, it forms zinc chloride in water. With bases, that the sodium hydroxide, it reacts to form sodium zincate and water. Okay. Now we come to the lab preparation of hydrogen. Here we can see we have used a round bottom flask where there is a granulated zinc is used. I'll tell you why granulated zinc is being used here. And the gas which is liberated when zinc and from the tristle, there's a tristle funnel through which dilute sulfuric acid or dilute hydrochloric acid being added to the granulated zinc. And what happens? Hydrogen is being liberated. This hydrogen comes out through this tube and collected over water. Okay. Now, this is the tristle funnel you can see, and through which the dilute sulfuric acid or dilute hydrochloric acid being added. Okay, it's passed to the tristle funnel on granulated zinc. Why granulated zinc is being used and not pure zinc? Because granulated zinc contains impure zinc, which contains copper. This impure zinc, granulated zinc, contains copper, which this copper acts as a catalyst in this reaction. That's why it speeds up the reaction. Very fast hydrogen is being produced. Okay, that's why granulated zinc is used instead of what? Instead of pure zinc. clear. And this, when hydrogen is being liberated, we can see effervescence or gas evolution is seen, and this gas is collected over water, that is downward displacement of water. Okay. Now, as hydrogen is virtually insoluble in water, why this is collected over water, that is downward displacement of water? Why? Because hydrogen is virtually insoluble in water under normal conditions. That is 20 ml will dissolve in 1 liter of hydrogen. One liter of water. 20 ml of hydrogen will dissolve in 1 liter of water. So virtually insoluble in water. That's why it is collected over water. And hydrogen is not collected over air. Why? Because it combines with air, forming an explosive mixture. Though it is lighter than air, but we will not be able to collect hydrogen over air because it combines with air to form an explosive mixture. That's why it's not collected over air. Now, what are the impurities which are present in hydrogen which we produce? See, when the hydrogen is being produced, hydrogen contains the impurities as H2S gas, sulfur dioxide gas, oxides of nitrogen, phosphine, PH3, arsine is ASH3, carbon dioxide, and water vapor. All these, that is 7 types of impure gases are present in hydrogen, which makes hydrogen gas impure. Okay, so we need to remove all these to make hydrogen, to get pure hydrogen. So how do we remove it? Okay, so first, to remove this arsine and phosphine, we use silver nitrate. Okay, silver nitrate solution, silver nitrate will absorb this arsine and phosphine, forming their salts, and nitric acid is being formed. We'll get back the silver nitrate solution, but a compound of this arsine and phosphine will form with the silver, and this nitric acid will be formed, and hydrogen gas will be liberated. Okay, which will be removed. Pass through. Hydrogen will not react with silver nitrate, and it will be fast. And this arsine and phosphine will react with the silver nitrate solution, forming a nitric acid, which is a soluble form. And so we can remove this arsine and phosphine, and the hydrogen gas will pass over. Okay. Now, lead nitrate solution will remove what? H2S gas. That will absorb H2S gas, forming the lead sulfide, and again nitric oxide will be formed. Okay, nitric acid will be formed. KOH solution will remove 3 gases: sulfur dioxide gas, carbon dioxide gas, and even oxides of nitrogen. Okay, so what happens? Sulfur dioxide, KOH, it will react with to form K2SO3, potassium sulfite, and water will be formed. Carbon dioxide, potassium carbonate. Okay, carbonate will be formed, and water will be formed. Okay, then nitrogen dioxide with KOH formed, potassium nitride, potassium nitrate, and water will be formed. Potassium carbonate. Then a drying agent is also used to remove the water vapor which is present in the hydrogen, because it will be remaining moist. So we need to remove this water vapor from it. So common drying agents are fused calcium chloride, potassium hydroxide stick, or phosphorus pentoxide. So then after passing through all these, we will get what? Purified hydrogen gas, which is dried and collected over mercury. Will not pass over water, but will pass over mercury, and we will take a pure dried hydrogen gas. As we can collect it over mercury because mercury does not react with hydrogen. Now, Kong sulfuric acid is a drying agent. Okay, Kong sulfuric acid is a drying agent, but it is not used to dry the hydrogen, because what happens? Kong sulfuric acid reacts with hydrogen. Okay, and the purpose of the reaction is defeated, that is, it reacts to form water again. So hydrogen, we will not be able to get the hydrogen if we will get water. The purpose will not be solved. Okay, So conc H2SO4 is not used. So see, this will be done in this way. First, we need to impure hydrogen contains phosphine, arsine, so sulfuric, H2S gas, carbon dioxide, sulfur dioxide, nitrogen dioxide, and water. Passing over silver nitrate solution. This will absorb what? Phosphine and arsine. Then the gas is passed. The rest of the gas will, so this will absorb these two gases, and the rest of the gas passes to the next chamber containing lead nitrate solution, will absorb H2S gas. Then the remaining gas passes, that is containing carbon dioxide, sulfur dioxide, nitrogen dioxide, and water, that will pass through KOH solution, which will absorb carbon dioxide, sulfur dioxide, nitrogen dioxide. And now only the water vapor is remaining in the hydrogen, that will pass to anhydrous calcium chloride, which will absorb the water vapor and pure and dry hydrogen. Okay. Next is the precautions of this reaction. What are the precautions? First, the apparatus should be airtight. Why the precautions are taken? Because hydrogen, if it comes with air, it will explode violently. And if it is brought in near a flame, then something disaster. So to prevent that, it should be kept, the apparatus should be airtight without any leakage of the gas. No flame should be kept near the apparatus. Okay, the hydrogen should be collected only after all the air in the apparatus has escaped. Otherwise, it will come in contact with the air and explosion will take place. Okay, if a small amount of air is taken in the test tube, and if there is any flame nearby, then something disaster will happen. Okay, so this can be proved by collecting it, that if there is this apparatus does not contain any air, to prove it, we should collect a small amount of gas in the test tube and take it to a flame. If the gas burns quietly, then there is no more air in the flask. If there's a violent explosion, then there is some air present again inside the flask. Okay. The end of the thistle funnel should be dipped under the acid to prevent any H2S gas from escaping from the thistle funnel. Okay. Now, nitric acid, even the dilute form, is not used in the preparation of hydrogen from the metals because it's a powerful oxidizing agent. The oxygen formed as it decomposes, oxidizes the hydrogen to form water. So nitric acid, even in the dilute form, is also not used in the preparation of hydrogen because it's a powerful oxidizing agent. The oxygen which is formed will decompose. As it decomposes, when the nitric acid decomposes, oxygen is formed. This oxygen will oxidize the hydrogen to form water. Okay, and nitrogen oxide will be formed. So manganese and magnesium only react with very dilute nitric acid, that is 1% nitric acid, liberating hydrogen. The over dilution, why can this be used? Because over dilution of nitric acid will reduce its oxidizing reaction. Then that is why only manganese and magnesium will only react with very, very dilute. Then conc H2SO4 is a strong oxidizer and produces sulfur dioxide. That is also, it is not used in the preparation of hydrogen gas. It is also not used for the preparation of hydrogen. Why? Because it is a strong oxidizer and it produces sulfur dioxide, not hydrogen. Okay. Now, next, we have come to the industrial process of hydrogen to manufacture hydrogen. So, first is the electrolysis of acidylated water. Electrolysis of water, but water, I mean pure water, will not electrolyze. Okay, it will not dissociate into hydrogen and oxygen. So some acid has to be added to it. Less volatile acid has to be added to it. So here sulfuric acid, light sulfuric acid is added to this water, pure water, making it acidylated water, and electric current is passed through. Water will dissociate into hydrogen, ion, and hydroxyl ion. at cathode, as hydrogen ion is positive ion, so it will have an affinity. The cathode will an affinity. Cathode is a negative electrode, and it will have an affinity to attract the hydrogen positive ion. So hydrogen will be liberated at the cathode. And hydroxyl ion is negative ion. And anode is a positive electrode, so it will attract the hydroxyl ion towards it, and this oxygen will be formed at the anode. Okay, so the reaction occurs in this way. At cathode, it will be H plus. By adding electron, it will form H ion, H atom, and H plus H, it forms H2 element, hydrogen gas. At anode, OH ion is formed, which will give one electron to form OH atom, and OH plus OH combining water and oxygen, nascent oxygen will be released, with nascent oxygen combines to form oxygen atom, element. Okay. So the reaction in total forms 2H2O, which is accelerated water, and electric current is passed through. At cathode, H2 is formed, and at anode, O2 is formed. The main advantage in this reaction, in this process, is that oxygen is simultaneously produced at the anode, and both H2 and O2 are pure in nature. Okay, and this proves that this reaction proves that water is a compound, which is made up of hydrogen and oxygen. Here, next we come to the Bosch process. It's the main process which is used, another important process which is used to prepare hydrogen in the industry. Okay, now the steam is passed over hot coke, which is around, not red, but hot coke, which is about 1000 degrees centigrade, which is used, hot coke is placed in converter. Okay, it's a big, what do you say, a big jar, okay, where it is known as converter, where this hot coke is kept 1000 degrees centigrade. At 1000 degrees centigrade, steam is passed over through it, and what is formed? Water gas is formed, which requires heat. This reaction is an endothermic reaction. It requires, it absorbs heat more. Lots of heat is required. 1000 degrees centigrade temperature is required for it. So carbon monoxide and hydrogen gas in combination is produced, which is formed known as water gas. Now, this water gas is mixed with more excess steam. With excess steam, it is used, and it is passed over iron oxide as catalyst and chromium oxide as promoter at 450 degrees centigrade. Okay, then carbon dioxide and hydrogen is produced. Okay, and a lot amount of heat is produced. This is an exothermic reaction. Okay, here this reaction is exothermic. So water gas is passed over steam. Okay, it's mixed with steam, and it is passed over iron oxide and chromium oxide. Iron oxide acts as catalyst, and chromium oxide acts as promoter. At 450 degrees centigrade, carbon dioxide and hydrogen is produced. This carbon dioxide is separated from hydrogen by different methods. First, this water gas is forced through cold water under pressure. What is the pressure required? 30 atm pressure is required, which will dissolve the carbon dioxide, soluble carbon dioxide, more soluble carbon dioxide, and hydrogen is left behind, because hydrogen is very less soluble and very sparingly soluble in water, but carbon dioxide is more soluble in water, so it will dissolve in water. Under pressure, it is happening. Okay. Then another process is carbon monoxide and hydrogen, that is water gas, is passed through KOH solution. KOH solution will remove the carbon dioxide by reacting with it, leaving behind hydrogen. Okay, so the reaction occurs in this way. So carbon dioxide, it will absorb KOH to form potassium carbonate, and water will be formed. Or carbon monoxide and hydrogen, that is water gas, is passed through ammonical cuprous chloride, CuCl solution, to dissolve the carbon monoxide, that is uncombined. Okay, so what happens? Carbon dioxide has been removed in this way, and the uncombined carbon monoxide that has been left, okay, that will be removed by passing this water gas over ammonical cuprous chloride solution. Okay, and hydrogen gas is left behind. So hydrogen gas is free from carbon dioxide and carbon monoxide gases. Okay? So this is how the preparation of hydrogen is done. Okay, and why we have also come across that why we need to produce hydrogen. What is the requirement of studying this preparation? Okay, so I think you are clear of this with this discussion. Okay, if you have any doubt, please do write in the comment box, or you can write at kasturi74@gmail.com. KASTURI kasturi74@gmail.com. I will reply as soon as possible. Okay, and if you are a new viewer to my channel or not subscribed yet, please do subscribe my channel. Okay, and if you're liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. Okay, and please don't forget to meditate before you start your day. Okay, so thank you for joining. Have a good day.